There are so many mysterious objects in our universe that you probably don't know about. The Dawn spacecraft was 2 weeks away from entering orbit around Ceres, a previously unexplored world in the asteroid belt between Mars and Jupiter. As the spacecraft made its careful approach, capturing images of the cratered and icy world, scientists watched in awe as the dwarf planet came into focus for the first time. That's when they saw it up close. A spattering of ghostly bright spots emanating from the surface, and the brightest one, smack dab in the middle of a crater, seeming to stare back at them like a glowing eyeball. Over the next year, Dawn dipped closer and closer to Ceres, descending to an altitude of just 240 miles and capturing images 1,000 times sharper than the first. The close-ups revealed the brightest spot to be a dome covered in fractures and surrounded by the jagged scar of an impact that had scraped away at the dwarf planet's surface. Still, scientists wondered, what was it on the fresh surface that made the spot, and others, so reflective? Once again using spectroscopy to reveal the area's chemical makeup, scientists discovered that the scar was covered in a glowing film mostly made of salt. The salt, they suspected, was coming from liquid that had risen up to the surface and evaporated, leaving behind a salt crust. But where was the liquid coming from? To answer that question, scientists looked at variations in the gravity around Ceres measured by the Dawn spacecraft. That's how they discovered a deep reservoir of brine, or salt-enriched water, oozing up from below and feeding the salty spectacle. Everyone else had left for the night, and Lujhendra Ojha was alone in his university's planetary science lab when something caught his eye. He was combing through images from the Mars Reconnaissance Orbiter, a spacecraft that circles the red planet capturing scenes of the alien landscape. That's when he noticed in 2 images of the same swath of Martian terrain, taken at different times, that dark streaks appeared to be oozing down a slope. Though he was only an undergraduate student at the time, Ojha had uncovered something big. But it wouldn't be until several years later that he knew what that something was. By 2014, Ojha had moved on to graduate school, but his focus was still on the unsolved Mars mystery. He and his colleagues had discovered dozens of sites where the oozing was visible. Water was the leading theory, but they needed evidence. To study a place like Mars, a place that's still inaccessible to humans, scientists often use a technique called spectroscopy. By identifying subtle variations in the pattern of light reflected by an object or surface, they can determine its chemical makeup. Using the spectrometer aboard the same Mars orbiter that captured images of the streaks, the team found the evidence they needed: hydrated salts. Similar to the way salt melts ice on a road, hydrated salts would lower the freezing point of a liquid brine substance, creating a flow of salty water. The finding, published in 2015, is the strongest evidence that liquid water might exist on Mars. But the question remains, is it drinkable? In 1930, amateur astronomer Clyde Tombaugh was comparing 2 images of the same patch of sky when he saw a speck of light moving across a field of blackness and stars. That speck was Pluto. In the years after Tombaugh's discovery, NASA would send spacecraft to every planet between Mercury and Neptune, humans to the Moon, and rovers to Mars, but Pluto, out there in the far reaches of our solar system, remained a great mystery. So in 2006, NASA launched a spacecraft that would finally reveal Pluto's secrets. It took New Horizons more than 9 years and 3 billion miles to arrive. But when it did in 2015, Pluto's breathtaking features came into view for the first time. And one of the strangest features? Fields of razor-sharp blades of ice, some as tall as a skyscraper. The first question was, what were these blades of ice made of? For the answer, scientists turned once again to spectrometry. That is, using the light waves reflected from an object to determine its chemical makeup. By looking at the light waves picked up by New Horizons as it flew by Pluto, scientists found the culprit: frozen methane. But that didn't explain the jagged spikes. Methane, like water, can also freeze in blob form. Earth also has fields of ice blades like the ones found on Pluto, though they're much shorter, only a few feet tall, and made of water ice. They form through a process called sublimation. In sublimation, when ice heats up, portions of it turn immediately into a gas rather than melting into a liquid first. Scientists theorize that Pluto's ice blades formed in a similar way as the dwarf planet's climate warmed over many millions of years. The ice may have started as a giant blob, but rising temperatures ate away at it, leaving giant daggers in their wake. Scientists had a feeling there was something out there, in the darkness between the stars. Just as they wondered about life beyond our planet, they also wondered about planets beyond our solar system, orbiting other stars, maybe even right next door to ours. But with such vast distances between stars and no spacecraft capable of traveling to even the closest one, they needed a way to see, or maybe sense, these planets from afar. In the 1950s, a Russian astronomer proposed that it might be possible to reveal these distant planets by studying the light coming from their parent star. A planet as large as Jupiter zipping around its star would cause the star to wobble, and that wobbling would shift the color of the light reflected from the star from red to blue. If scientists could build technology sensitive enough to correctly sense those color changes, called a Doppler shift, they could finally know if planets exist beyond our solar system. And in 1995, they did. By 2009, scientists had discovered more than 100 of these distant planets, called exoplanets, and a NASA mission was about to reveal thousands more, some that may even be like Earth. But instead of watching for color changes in starlight, NASA's Kepler Space Telescope had a new trick up its sleeve. It watched for the starlight to dim. When someone crosses between you and a light, the amount of light you see decreases. In the same way, when objects pass in front of their stars from our perspective on Earth, we see a dip in the light coming from those stars. Using this technique, Kepler, other observatories, and even amateur astronomers have discovered thousands of exoplanets, all of which have their own oddities and mysteries to uncover. In 2005, an instrument on NASA's Cassini spacecraft detected something unusual about Saturn's moon Enceladus. The moon, previously thought to be cold and dead, seemed to have an atmosphere. Still, it was unclear what exactly was forming this atmosphere. The team needed to get closer. Later that year, Cassini made a close pass by the moon, collecting data that suggested it wasn't an atmosphere they were detecting, but a plume spraying from the moon's warm south pole. What was the source of this mysterious plume? Cassini made many more passes by Enceladus, each time capturing more detailed images of the plume. As we became more confident that the jets wouldn't destroy the spacecraft, we swooped down lower and lower into the plume, said JPL scientist Bonnie Baratti. The images revealed a towering spray of fine, icy particles spewing from the moon's south pole and reaching as high as 300 miles above its surface. The team also used the images to identify the location from which the plume erupts, the hottest spot on the moon, where deep fractures called tiger stripes straddle Enceladus' south polar region. There's still much about the plume that remains a mystery, and with the Cassini mission having reached its end, it may be a long time before we can next unravel the secrets of one of Saturn's most fascinating moons. Read on for scientists' latest theories about what's powering the plume and what it could mean for our search for life beyond Earth. Perhaps the biggest space mystery of all time is the question of whether we are alone in the universe or even within our solar system. Recently, we found clues that the answer may, in fact, be out there, maybe even at Jupiter and Saturn. Water is a key ingredient for life as we know it. Astrobiologists, who study the possibility of life beyond Earth, say other ingredients include the existence of certain chemicals and a constant source of energy. Until recently, Earth was the only known world with liquid water. Now we know that at least two other worlds, Jupiter's moon Europa and Saturn's moon Enceladus, have global oceans. And there are clues that bodies of water exist elsewhere. But what about the other ingredients for life? The icy moons Europa and Enceladus may have those, too. When the Cassini spacecraft showed there was a plume of water vapor and icy particles shooting from Saturn's moon Enceladus, scientists had to know more. Originally, Cassini was scheduled to fly by Enceladus 3 times, and, instead, it made 23 passes by the moon, each time finding out more about its chemistry and the plume. Among the discoveries were a salty ocean beneath Enceladus' icy shell and strong evidence that the moon has what are called hydrothermal vents. There are hydrothermal vents at the bottom of Earth's oceans, too, and the chemicals released from them feed tiny shrimp and other creatures. If the same vents exist on Enceladus, the moon would have the chemistry and energy sources required for life. Alien shrimp, anyone? Meanwhile, on Europa, Clues collected by the Galileo mission to Jupiter suggest Europa also has a global ocean. Later, NASA's Hubble Space Telescope detected possible plumes there, too. To find out more, NASA is developing a new spacecraft called Europa Clipper, which is designed to study the moon and probe deeper into the mystery. NASA's Cassini spacecraft unraveled many mysteries about Saturn during its 13 years orbiting the planet. But one of the most visually interesting mysteries was an unusual spinning hexagon at the planet's north pole. All planets that have atmospheres probably have a vortex of some kind, said Todd Ratcliffe, a planetary geophysics researcher at JPL. But Saturn is the only planet with one shaped like a hexagon. Scientists have known about the hexagon since the early 1980s, when NASA's Voyager 1 and 2 spacecraft imaged the strange formation during flybys of the ringed planet. But it wasn't until 2007, when the Cassini spacecraft captured a closer view of the hexagon in infrared light, that scientists began to hypothesize about what was creating the unusual shape. For the first 5 years of Cassini's mission at Saturn, the hexagon was impossible to view in visible light, the wavelengths visible to the human eye. It was winter on the planet's north pole. A season that on Saturn lasts for about 7 years and covers the region in darkness. So in December 2009, with the return of spring and the sun again illuminating Saturn's north pole, Cassini captured the first highly detailed images of Saturn's hexagon up close, revealing never-before-seen features. Meanwhile, physicists at the University of Oxford unraveled the mystery a little further by creating a simulation of the interaction between an atmosphere like the one on Saturn and a spinning jet stream. The physicists found that by varying the speed of the jet stream and atmosphere, they could create different shapes, including a hexagon. It turned out that Saturn's hexagon was carved by the path of an intense jet stream mixing with the surrounding atmosphere. And at its center, a massive, rotating storm that has existed for decades. In 2013 and 2017, Cassini got more chances to take up-close images of the hexagon. Those images were stitched together to create the 2 videos above from 2013, left, and 2017, right. And as often happens in science, one mystery solved leads to another still in need of an answer. What caused the color change in the hexagon over those 4 years? In March 2004, NASA's Mars Exploration Rover Opportunity had just recently completed its 283 million-mile flight from Earth to the surface of Mars. Over the next few days, Opportunity snapped dozens of photos of Mars' surface, but only one truly shocked and confused the mission team, an image showing what appeared to be a fuzzy, white bunny. Before we first saw the images of the elusive bunny, all our thoughts had been focused on the challenges of getting Opportunity up and off of its lander, said Rob Manning, lead engineer for entry, descent, and landing of the rover. At first sight of the soft white bunny, our worries quickly turned to wonder. We just did not know what it was, and at the moment, we did not have a lot of time to think about it. We had to get the rover off of the lander first. Then, when Jeff Johnson, a scientist with the U.S. Geological Survey and a member of the rover's panoramic camera team, tried to snap a clearer image of the bunny, it had disappeared from sight. Johnson, who was intrigued by the mysterious object, was assigned to track it down. He soon found the bunny in other images from the rover's navigation camera and measured its size, about equal to a tennis ball, using software designed by NASA's Jet Propulsion Laboratory. Then, there it was again. In an image of the rover's lander, Johnson spotted a small white object similar in size and shape to the bunny snapped in earlier photos. The team suspected a light wind had blown the object to its new home under one of the ramps designed to help the rover roll onto the Mars surface. Scientists never did find out for sure, but most likely, the object was simply a piece of soft material from the landing vehicle. We gathered soon after the rover landed and looked at the pictures, said Manning. The landing vehicles are made of many different materials, but the most likely candidate was the white felt that surrounded each of the 3 airbag gas generators. Jupiter is known for its colorful spots and bands of swirling clouds and storms, but in July 2009, amateur astronomer Anthony Wesley discovered a spot unlike the others, one that seemed to have appeared overnight. We received an email from Wesley about this impact on Jupiter, said Glenn Orton, an astronomer at NASA's Jet Propulsion Laboratory. and we had happened to have observing time at NASA's infrared telescope facility in Mauna Kea, Hawaii, the next night, so we were very lucky. Using the telescope to view Jupiter in infrared, which quickly shows areas where there are high-altitude particles and relative heat, Orton and his team saw the giant scar clear as day. The question that remained, what caused such a giant bruise? The answer was hidden beneath a chemical soup of gaseous atmospheric compounds. At the time, having no spacecraft at Jupiter to examine the scar up close, Orton and his team quickly proposed observing time at ground-based observatories that could view the impact in different wavelengths to bring out various features, a technique known as spectroscopy. They compared the data with measurements collected when comet Shoemaker-Levy 9 also impacted Jupiter in 1994. They were shocked and intrigued by what they discovered. "We think this was actually an impact by an asteroid rather than a comet," said Orton, who, along with his team, discovered that the impactor must have had a chemical composition and density closer to that of a strong rocky body. Both the fact that the impact itself happened at all and the implication that it may well have been an asteroid rather than a comet shows us that the outer solar system is a complex, violent, and dynamic place, and that many surprises may be out there waiting for us. Miranda, one of the most unusual moons in the solar system, is the smallest and innermost of Uranus' 5 major moons. Our only up-close images of Miranda are from NASA's Voyager 2 spacecraft, which flew by the moon in 1986. Even to the casual observer, it was clear that the moon held many mysteries, one of which went unsolved for years. The first thing scientists noticed about Miranda is the hodgepodge appearance of the surface, said Bob Pappalardo, a JPL research scientist. It was originally thought that perhaps Miranda had been blown apart by a huge collision with a comet and reassembled in the way that we see it. That theory later proved unlikely. Analysis showed that even a body once constantly bombarded by rocky objects would no longer feature those scars today. So then why did Miranda look so peculiar? Scientists now suspect that the answer to Miranda's Frankenstein-like appearance lies within the moon's cold interior and its once egg-shaped orbit. In an egg-shaped, or eccentric, orbit, the gravitational pull on the moon would vary, strengthening when the moon passed closely by Uranus and weakening when it was farther away. This variation distorted and heated the moon's icy surface. Ultimately, careful study of the shapes and relationships among the ridges and grooves suggested that blobs of ice rose up inside Miranda to shape the surface that we see, said Pappalardo. All this activity continually warped Miranda's surface until eventually the moon shifted from its odd orbit into a nearly circular orbit. Without the tugging and warming, Miranda's distorted features essentially froze into place to give us the Frankenmoon we see today.